Hello students. Today we are going to solve one more problem from Doppler effect, and this question basically asked in IIT JAM 2014. Okay. So in that question, uh, there is a source of sound. S is a source of sound emitting frequency. The frequency of the sound that is given, that is small f, and there is a wall. Okay. There is a wall. Okay. And this source of sound is actually fixed, is stationary. There is an observer here. Okay. And this sound actually first make incident at wall at an angle of 30 degree. Okay. Then further it get reflected and it is going like this. Okay. And this angle also they provided, that angle is basically 30 degree. Okay. And observer is moving towards wall. Observer is moving towards wall with some speed u. Okay. So they have also given the speed of sound, that is Vs. So when observer is actually moving towards wall, then it feels frequency of the sound or apparent frequency observed by this observer, that is actually given, that is f dash equals to 9 by 8 into f, where f is the original frequency of the sound source. Then they ask what will be the speed of this observer, what will be the value of this u in terms of Vs. Okay, that you have to calculate. So again I am repeating, there is a source of sound and it is stationary emitting frequency f. The speed of sound is Vs. This sound first striking this fixed wall at an angle of 30 degree, then again it is coming like this. And there is an observer here. Observer is moving towards wall. Okay, towards wall with speed u. And it feels, observer feels that apparent frequency, that is 9 by 8 into original frequency. So you have to calculate this speed in terms of speed of sound. Okay. So it's a very interesting question actually. So when this frequencies, this source is fixed, when it is striking this point of this wall, this point will act like a source. So like sound is coming, here it is reflecting. So this reflecting point itself, like we have like a source, that is, let us assume S prime. Okay. And S prime will emit frequency, that will be how much? That will be itself f, because there is no relative motion between this point and source, original source. So this source will behave like a S prime with same frequency as the frequency of emission. Okay. Now you can see this is like a source and you have an observer. Source is fixed and observer is moving with some speed, that is u. Okay. Line joining between that observer and the source is this line. Okay. So there is a relative motion between source and observer. So the speed component of this observer towards line component will be how much? So this angle, if this is 30 degree, this is 90 degree, obviously this angle will be how much? This will be 60 degree. This is 90, this is 30, so obviously it will be 60 degree. So the speed of observer along the line joining between source and observer, that will be how much? U cos theta, or theta here is how much? 60 degree. Okay. So basically that component is u by 2. Okay. Now I can use this formula of apparent frequency f dash. F dash will be how much? So it will be original frequency, that will be f, then you have speed of sound Vs. Now Now observer is approaching towards source. So I have to use U by 2. Okay. Then you have Vs. Okay. And given that f dash is nothing but 9 by 8 into f. 9 by 8 into f. So now I can calculate. This f will be cancelled. So basically what I'll get Vs plus U by 2. That should be equals to 9 by 8 Vs. Okay. So it means if you bring Vs this side, you will get that speed of observer towards this wall, that will be nothing but Vs by 4. So really interesting question. So whenever there will be some reflection point, this point itself you can choose like a source. It's a really a good concept of Doppler effect. Okay. So that speed we observe, that will be Vs by 4. Thank you.